Oh, okay. So hello everybody. My name is Dempsey. Um I'm an AV guy, currently working for Ursa Major for this little training module here. Um my main position is project manager for Focus Event Technologies, which is the limited liability corporation that I started this year. We handle audio, video, lighting, and streaming for events around Washington, I guess the DMV area generally. So I have some topics that I'm going to cover today. I'm going to cover audio engineering for breakout rooms and ballrooms and meeting rooms at hotels generally. I'm going to cover different types of microphones, gain staging, compression, EQ, matrix mixing, busing, and speakers. Also, we'll cover some mic placement and techniques. And for streaming, I'm going to cover the different types of streaming platforms: YouTube, Cvent, Facebook Live, and their specific requirements, and practice the integration of multiple audio, video, and graphic sources into a cohesive live stream. I'm going to teach you how to troubleshoot common streaming issues such as latency, buffering, and audio sync problems. And finally, I'm going to cover recording audio and video separately or just audio, teaching the fundamental principles of recording both audio and video, including setting levels and selecting appropriate recording formats, so that you can gain proficiency in operating recording devices such as cameras and audio recorders, so that you can understand best practices for managing recorded files, including storage, backup, and file organization. So let's dive right in. Okay. The recommended what do you call it? Syllabus or something? Um, is to review the principles of audio signal flow. Okay. Okay. Signal flow. I don't even like this chart, but we're going to start here. So every source that you're going to try to record is going to originate in the real world. If you're using a microphone. So here in this chart, it shows the sound source, which is, in this example, is the vocalist. The instrument, or what they call in the industry, the transducer. They don't actually call it that in the industry, but this is what they teach at school. This is a transducer. It turns analog signals into electrical signals, which are then amplified with a preamplifier. And if you're recording, it gets converted again, this goes from analog to electrical. Um, this boosts the electrical signal, the voltage, and your A to D converter converts your analog signal into a digital signal. So from just electrical impulses into ones and zeros, data that can be then transmitted via your computer to your bus, which is generally like a recording device, a virtual recording device in your computer, writing your zeros and ones into a file, which you can then bring up later. Another way of looking at this is by just going to, let's say, an analog mixer. So here's a maybe typical analog mixer that you would see in the real world. Go ahead and max this out. So here's your basic mixer these days. You have your mic or line input. This is nice because it has this single connector, which you can either plug a balanced cable in, which is like a guitar cable, or an XLR, which is a 3-pin cable that separates positive, negative, and a neutral line from your microphone to the mixer. The pad function is there for if you have a very, very sensitive mic or instrument that is outputting a lot of signal that you want to kind of reduce before it hits to the preamplifier. You're only going to use this if the signal from your source exceeds the capacity of the preamp. And then you're going to control the gain with your gain, what's called a potentiometer, which is the dial here in white, which you can add gain to your signal. So if you have a low signal, you can boost the gain and increase the signal. If for some reason your gain's already all the way up, which it never should be, you just bring that down until the signal, more or less, you want the signal not to exceed 0. 0 is what we call nominal. Nominal is like the peak. Anything beyond the peak begins to distort, turning your waves into squares. And you don't want that because you lose data that way. And it doesn't sound pleasant. Sometimes it sounds good, like in music, you distort a guitar to kind of change the tone. But in most circumstances, in the real world, when you're providing AV services for people, especially at conferences or hotel situations, you never ever want to distort the signal. So when you're dialing in your mic, make sure that the person who's testing the mic, whether it be you or your audio assistant, is speaking into the microphone, and you're dialing in your gain until you see the lights kind of sit, somewhere between -20 and -6. Okay? A compressor is here on this board. You won't see them on a lot of like Mackie 1402s or some of the basic boards, but compression is good to know, so I'll go over that here. So these are going to be two probably good. Here's maybe a good example here. So compressors reduce the amount of volume in a signal once it hits a certain threshold. So if your input level, let's say this is your output level, whichever, this is your input level. So like we were looking at those lights earlier, they go from -20 to 0, right? Excuse me. So when your audio signal is like this, imagine this is the lights. These are the lights here. This is your meter. I know the numbers don't match up, but that's not really important right now. The higher this goes up here, it should, if your compressor is 1-to-1, your output is going to match your input, right? So on your X value, as far as this goes here, it should match on the Y value. I think that's how math works, or diagrams work, X and Y axis. And on a threshold, so this mixer doesn't really have, these are, I wonder actually what the Yamaha MG10 compressor is set to. It might just be it has its own settings here, but the more advanced mixers, like a digital mixer, allows you to change the parameters in the compressor. However, the higher the volume here, it should match on the output level. And mathematically, you would set your threshold to a specific volume level. Let's say here is set 20. And anything beyond that, it's reduced as a like percentage or a fraction. So 2-to-1 compression is basically going to reduce your volume by half. 4-to-1, 25%. 8-to-1, you get the idea. Until you get to infinite to 1, which basically just does not allow your output level to exceed your threshold. So once it hits your threshold, it gets permanently squashed. Not permanently, but it gets squashed right there at the output level. This is like what a waveform would look like. In that scenario, this is your threshold. Imagine your waves. This is the volume, the amplitude. This is the amplitude. This is your peak. When it hits this threshold, an infinite to 1 would squash this audio signal right here and would not allow it to pass this. Okay. I really wonder how my stream and recording are doing. I feel like it's having a lot of trouble with all this data, but we'll find out later. So right now I'm at 14 minutes and we're just at gain. Okay, no, we hit compression. Okay. Further down the mixer, and you'll see this mixer just represents your, the inputs go down. It's kind of like a, let me copy this. Man, you know what? I wish I had Paint. I have my Mac right now. But basically, imagine this is your signal chain. It starts at the input, goes down to the pad, your high pass filter, which is a part of the EQ processing. And then again, it hits the compressor. Oh, we forgot phantom power. Let me add this to the... the list. Phantom power is required for certain mics. Compressor mics specifically, not compressor mics, condenser mics specifically, which are mics that pick up a higher transient. They basically just pick up the signal faster and are overall more clear microphones. They have a lot brighter sound. You can hear things very clearly with them. They're used for instruments such like as, vocals, but also anything bright, anything that requires a fast any sound that requires brighter sounds things that are in the higher register exist at a higher frequency. So in physics, like let's say vibration, a low note is going to vibrate slowly and a high note's going to vibrate very fast. So the higher the note or the higher the tone, the brighter the tone, it's going to require a faster mic, if you will, and condenser mics are faster mics, if you think of it that way. And they require phantom power plus 48 volts, which is here on the screen. If you have a condenser mic and you do not push that button, no signal is going to come out of that microphone. It requires 48 volts to operate and to output any signal at all. It is a mistake to turn up the gain and then turn on the phantom power. That may cause horrible feedback and just very loud, angry noises coming from your speakers. So remember, you can just keep it on if you want. It doesn't affect your dynamic microphones at all, generally. It's there as a feature. Some mixers do not have it, and you need to add phantom power with a separate box. But yeah, just always remember to press that button before you start dialing in the gain to a condenser mic. Some condenser mic examples are, at least in our world and in the hotel industry, are your MX412, the Shure podium mic. Any podium mic generally is going to be a condenser mic. The SM57 and SM58 are dynamic microphones. They do not require this. I don't know why I got a thumb. Okay. Maybe it has something to do with YouTube. Yeah. So, moving on. So we hit phantom power, we hit compression, EQ. So here's your, this is a parametric EQ, which is featured here on this Yamaha console. My advice is to start flat. You boost up your gain and you use your ears. And you basically just want to kind of evaluate, hey, eventually you're going to catch on and you're going to be listening to stuff and you're going to say, man, that sounds really boxy, or that sounds really, bassy, or it sounds really crisp, or whatever. You're going to have all these words that you're going to start coming up with to describe the tone of what's going on. So when you boost up your gain and you're doing your gain staging here and you're listening, you're going to notice that, hey, the low end here is really coming through. I don't need that. So you can just reduce your low knob starting at 100 hertz Just lowering it a little bit, boost your gain. Boost your level. So you have your gain, you have your level, and then you have your master fader here. So small adjustments work, but you can notice that you can get more signal out of your microphone by adjusting the tonality a little bit. So that's something to keep in mind. If you have an audience or you have a client that says, hey, I really need you to bring up the volume, it's just not loud enough in here, and you bring up your level, you're going to start hearing certain frequencies kind of coming out. And you can kind of adjust that just with the tone to maximize the volume that you can get out of that microphone, to maximize the volume for your audience. And I'm just kind of going over the basics here using this analog console. Your next point in the chain are your auxes. So this is what we call busing or matrix mixing. So this is your single channel. So let's say channel 1 goes all the way through this processing, right? Gives you this aux, and then it goes down to pan, and then it goes down to level, right? So this is essentially where you're sending signal. Your outputs are going to determine which knob you turn up. Your aux level, sometimes we use these for records, sometimes we use these for webcasting, sometimes we use these for monitoring, for stage monitors, panning. This is going to be on your mixer. You're going to have stereo outputs, and that's usually a stereo pair, which is left and right. Or we can just look at here. On this channel strip, you have one aux, which is here on this channel strip here. I am laggy because I'm streaming and recording here in OBS. So hopefully it turns out okay. And I'm just doing this on the fly. This is not supposed to be perfect. Probably not. I probably shouldn't have even gone live here, but if there's anybody watching, this is not like a professional grade instruction video. This is my practice for a presentation that I'm giving on next week for an AV training for a small AV company. Anyway, your stereo outputs are left and right, so that's your pan, your left and right pan. In meeting rooms, you're generally not going to be panning stuff unless you have a stereo input that requires 2 channels. And even then, so if you have a 1/4 inch or a TRS or TRRS to stereo XLR, that's like probably the only case that you'll need to use the pan knobs in AV. Generally because you want a single source coming out of your speakers. You're not looking for a stereo image. Even if you're doing a movie screen at a hotel, you generally just want the single source coming out of one speaker because you have people on the right, you have people on the left. This isn't like an IMAX scenario. This generally, it depends on what you want, but generally you want the same signal coming out of every speaker so that folks can hear everything. Every single person in the room has the same experience. So you have your stereo outs, and then you have your aux send, which is a separate mix that you're mixing with these blue knobs here. Your only aux knob on this board. And okay, so you're adding signal to each output via these knobs, right? So your aux is going to a single output. Your level is going to a stereo output, and you're choosing which speaker it's going into using the pan knobs. So that's your matrix mixing busing scenario for most small footprint consoles that you're going to find out in the meeting rooms, out in the small meeting rooms there. Speakers. You're going to be seeing a lot of these. You probably have a lot of these in stock. This is the so when you look at the specs, okay, maybe this doesn't have a good, there we go. So yeah, so this speaker is pretty common. This is what you're going to be seeing, either this or like the JBL, PRX, or something similar. But basically, you're going to have a 10-inch or a 12-inch or a 15-inch driver. Generally, you're going to see 2 to 4 of these in any ballroom, meeting room, or that's what your salesperson should be selling. If it's a small meeting room, maybe you only need one. But you did kind of determine that by looking at the tech specs. So these are powered speakers, so they just plug in the wall. You don't need a separate amplifier to drive these. This one's got 3 channels in it, so you can, for certain scenarios, if you're going to do like a split room or something like that, like an air wall or something, and you want to plug in 2 mixers to a single speaker and kind of use one when it's one big room and then 2 separate ones after you break the air wall. I don't know, some scenario like that. But I think they use the 3-channel mixers on these for if like you're plugging in an instrument, a synthesizer, a vocal mic, whatever. But you generally are only going to use one single XLR for these. A ferrite woofer. So ferrite and neodymium are the magnetic components of your speakers. Ferrites are generally lower quality. Neodymium are the higher quality stuff. And so that's why it's in the sensitive tweeter, which projects the high frequency stuff, versus the ferrite, which is going to not as necessary. It's a slow, dumb signal that just needs less precision. So your wattage, generally, your wattage is not a huge determining factor with speakers. The higher the wattage, basically the more audio that it can handle, obviously. The higher you can drive the speaker. But you're generally never going to use that much power. It's basically the higher the wattage, the better quality. Because if your speaker can handle, 2,000 watts or something like that, it's a good speaker. It's kind of a good way to think about it. This one has an XLR output, which is your throughput. So if you need to link speakers, you can just send one XLR line and then link a second speaker, and it all exists on the same circuit. your frequency range. So, it's nice that this provides a 45 to 20 kilohertz frequency range. So the human ear can process sound from 20 hertz to 20,000 hertz generally. It kind of dips off after 10, and it kind of dips off around 50 in the other direction. You can still sense those kind of things like on more of a, I don't want to say subconscious level, but not in, these are harder sounds to hear. With the bass, obviously you feel it more than you hear it. And the high frequency stuff, kind of the same. The crossover frequency is the frequency at which the high frequency driver and the low frequency driver converge, and they kind of overlap. So if you have a crossover frequency, obviously like 5K, that means you have a pretty nice low end woofer or whatever that can go at such a dynamic frequency. Not really huge. It doesn't really matter too much here. Maximum peak SPL 128 decibels. That is very, 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 very loud. And hopefully you never need to use the full power of that speaker. Speaking at a volume here in this room, for me, is about 60 decibels. Obviously, you can't hear that 50 feet away. But if I needed to drive a speaker across a 100, 200 foot ballroom or something like this, then we might get into the 90 decibel SPL range in order to project that all the way across the room. So this is a really good thing to consider. Here is your horizontal coverage angle and your vertical coverage angle. So this is really important to kind of determine how many speakers you need in a room. If your horizontal is 90 degrees, so imagine a right triangle. This is, let's say the speaker is pointing down. It's going to cover this area here, so it's going to give me a good coverage. So I would place my speaker up here so that I can be heard. I can hear all the way around here. I know this. I'm not a very good diagram here, but I don't have Microsoft Paint or anything to draw with to kind of show you exactly what I mean. Let me see if I can. Let's do like a. Yeah. Maybe this is a good diagram here, or even here. You see these. Here, this is a good one. I'm gonna save that image. This is probably a good image too. Shoot. But your speaker coverage is really important to calculate when you're kind of determining how many speakers you need in a room. Okay, I'm sorry I clicked on this. Where did that one picture go? I know I saved it, but there, this one. Thank you, Personas. So as here's your subwoofer. All of your low frequency stuff. Low frequency stuff spreads cleaner, has a wider coverage than, let's say, a high frequency, which is more narrow, and a like mid to low frequency woofer, which is somewhere around 90 and 120, depending on like the speaker design, right? Um, I guess this wasn't a really good picture. This one's more of a better picture. Um, so you see the amount of coverage. I guess this is a good picture because here's like more of a 90-degree splay, and here's more of like a 120-degree splay. So this is how you're gonna kind of think about speaker placement when you're setting up a room, just to make sure that everybody in the room can hear. You're going to position these speakers. Sometimes I generally would probably put one here, one here, one here, one here, and kind of aim diagonally to get maximum coverage here. In this scenario, you see how red, I guess, is like high SPL, yellow is medium SPL, and blue is like low SPL. So the front row is getting blasted in the face with high volume sound. And these guys in the back are not hearing so well. So if you put 4 speakers in here, you're going to get some red zone in here, red zone in here, red zone here, red zone here, and then blue zones, in the middle, and then toward the middle there in the bottom. So that kind of covers audio generally. In the first part of this presentation, we hit about 38 minutes. So continuing on, streaming. So a lot of events these days, now that it's possible, want you to stream to Facebook, YouTube, etc. Vimeo, Cvent. If they have hybrid meetings, or if they just kind of want to show what's happening, it's like you no longer need a camera crew to show up, a satellite uplink to send it out to TV. Now we can just stream online anywhere in the entire world with a cell phone, essentially, or some sort of Wi-Fi, but ideally hardline. So streaming platforms. No. Live streaming platforms. So YouTube Live, which is what I'm streaming on right now, Facebook Live, Vimeo, which is like, I'm sure you've seen it, etc., Twitch, etc. So streaming services use this protocol called real-time messaging protocol. This is how we send data from our computers. It packages it into a format and then sends this out to platforms like YouTube, where you're listening to this now, maybe. When I'm setting up, and hopefully, let's... So you see, this is my streaming setup here, and right now I'm using OBS to stream to YouTube via RTMPS, which is like the more secure version, I guess. And I'm using a stream key to get that over there. I set up my stream at YouTube. I wonder if I can get, yeah, you basically have to sign up ahead of time. You have to get your stuff all set up. They have to approve you to make sure that you're not some crazy person, I guess. And then you set up your parameters here, your descriptions, your visibility, etc. And then you'll see down here some additional settings too, like closed captioning if you want YouTube to automatically caption your stuff. But you're gonna use this stream URL, which is essentially the platform's URL. So in this case, it's YouTube, and this is why it says RTMP : It's not like a web address per se, because web addresses are used by Internet Explorer, like Internet Explorer platforms like Google Chrome. That's an easy way to describe it. Whereas RTMP uses this kind of code or whichever format. So you copy this. This is what you're going to provide to your streaming tech. Is the stream URL and the stream key. This key looks like this. It's 20 characters long and with dashes, and it's usually just is easy enough to copy and paste that into OBS, or if you're using a video encoder. Let's see, so it used to be like a, what do you call it? Not Livecaster. Like a webcaster. Who makes the cube? A Teradek is a popular. Let's just go with Teradek cube. Okay. So this is a device that's commonly used in streaming. You connect your video signal here either via HD, SDI, HDMI. If you have audio separate from the HDMI, then you run it through your headphone jack or whichever. But this needs to be connected to your network. So you plug this guy in to a network switch that's connected to a internet line so that you can broadcast to the web. And you can connect. Usually, you can connect if you have your laptop on the same network switch. You can find your IP address here, connect to it by typing the IP address into your browser window, and then it'll give you, let's say, a Teradek. Let's find the Teradek GUI. Yeah, so basically you're gonna log in. Ay, Dios mío. So they have this web UI here. You type in the IP address into the browser window. Man, I wish I had a better view of this. One sec. It's not a GUI. Excuse me. It's web UI. So yeah, you're gonna open this up. So you see, here's your IP address here. It's gonna be found on the front of your device. Basically, just go through the settings, find your network settings, find the device or the device's IP address, load it into your browser, and then you're gonna see all the settings and everything to configure your encoder up. And then once you do this, you can set the resolution, the bit rate. 10 megabytes is usually pretty high. You can get away with about 3 to 6 at H.264. And I wish it would show where to. Oh, that's really weird. Yeah, I wish it would show where to enter your stream output settings, but it's not showing this in this photo here. But essentially, and you might not be using a Teradek, you might be using something different, but essentially the same parameters apply as in OBS, which is your RTMP URL and your stream key. Once you enter this, you hit OK, and then you start streaming, and then you should see it pop up on the web address that you're streaming to, such as here. So I see it here. I'm streaming. I've been streaming for 47 minutes and 51 seconds, etc. Okay. They want me to cover all the platforms are going to use the same kind of protocol. Cvent, Facebook Live. Once you enter into the admin, once you kind of sign up for these, I think Facebook Live is pretty easy. You go live on the web browser, etc., and you enter in this, enter the stream URL and key into whichever encoder you're using. It's going to pop up the same way. I think it's a little trickier with Facebook Live. I haven't had a Facebook account since 2000 and maybe 10 or 12 or something like that, so I don't really know or use it very often. Cvent, same thing. It's going to have a URL and stream key, and you're going to enter that in. They're going to want, looks like YouTube specifically is saying the stream's current bit rate, 2,691.74, is lower than the recommended bit rate, and it recommends that I use the bit rate of 6,800. I don't think it's going to absolutely be a major problem here. I think we're seeing it with no issues, so I'm not going to worry about it. But yeah, you want to make sure that you match your bit rate with whatever your platform is looking for. So if you go to Facebook Live bit rate, you're going to find this pretty easy, just a Google search away. So video quality recommendations for Facebook gaming streams, which is probably not what you're going to be doing, but so it wanted me to stream at 6,000 for YouTube. So it looks like if I'm going to be doing 30 frames per second, you want to do 6,000. Anything higher than that, you're going to want to hit 45 to 9,000. Essentially, just look out for any recommendations here for that. it says here that they want me to go over the practice of integrating multiple audio, video, and graphic sources into a cohesive live stream. I'm not really sure what they mean by that. I think if I had to guess, it would be probably like a multicam shot or something like that. So basically, just outputting whatever signal from a video switcher that's taking in multiple inputs. So let's say you have a analog way quick view, or you have a Blackmagic ATEM or something that has camera feeds, PowerPoints, whichever, and your graphics or your video engineer is switching between those, and your live stream technician is receiving that feed, or even, hypothetically, let's say, that your live stream, let's say you're using Blackmagic for your live streams. Multiple people can log into the same switcher. And use the same GUI and control the same switcher from multiple computers. So let's say you had a live stream tech specifically, and this is just like don't don't take this without a grain of salt. But let's say you wanted a scenario in which you were a graphics person, and your V1. So your V1 is kind of controlling what's going on the screens, and then you kind of want your live stream tech to have a separate feed of what's going on to the live stream. Obviously, the people in the room are probably not going to want to see the same things on the screen as the people at home. The people at home probably want to see maybe a pip, or like they want to see cameras, and maybe the people in the room just want to see PowerPoint. So you have a different feed going, and that's where you kind of get into auxes with your video switchers. And I'm looking here. This is not the right one anyway. So like, this is just your basic ATEM TV studio, ATEM TV studio, Blackmagic switcher. So this one has multiple outputs, right? And you're gonna see it in the GUI as like aux. Here, maybe this is. It's not what we want. Do I have ATEM? I don't think I have ATEM on this machine, and if I did, I don't have a switcher to connect it to show you. I have it, but let's see if it'll open. Yeah, the problem is I have it, but it's not connected to anything, so you can't really show you. I wish there was like a virtual. Yeah, I wish ATEM had a virtual. I wonder if they do. Like Analog Way has a. Anyway, my idea here was just have a separate technician that's going to connect to the ATEM software and control the aux channel with a separate laptop, so that they can kind of control what's being sent out to the stream. But you're going to have scenarios like that pop up, but you're going to want to keep that in mind. I'm probably going off on a tangent on something that you'll rarely ever consider, but just know that there are auxes on these video switchers so that you can send separate feeds so that you're not, and not to make your video engineer stumble to have like a separate technician to control what's hitting the auxes with a separate laptop controlling the software. Yeah, that's a long tangent, I know. Okay. So yeah, that was just like that specific note that we want to practice the integration of multiple audio, video, and graphic sources into a cohesive stream. So, but yeah, essentially you're going to have a video switcher. You're going to have multiple sources, camera, PowerPoint, etc. However you want to send that to the web through your webcast or your live stream. That is something to consider. Whether you're going to do it through OBS or whether you're going to do it from a video switcher, an aux, a program, whatever. So, common streaming issues: latency, buffering, audio sync problems. Latency is going to happen if you're pushing too much data over too small of a pipe. Buffering is going to happen if your network is handling too much traffic. So, or if you're streaming over Wi-Fi. If you're streaming over Wi-Fi, just imagine your Wi-Fi card is broadcasting at a very high frequency data and information. Those electromagnetic waves are bouncing off of different things in your house, in your apartment, in your ballroom, whichever, and hitting your wireless router at different times, causing latency, jitter, etc. To get around that, you have a hard line directly from your encoder or your laptop to the network. And if that network is being shared with 100 different participants, every ping to every different thing is going to, there's a traffic cop inside that network switch that's saying, hey, webcast, you can go. Hey, guy surfing Facebook over here, stop. Okay, now you go. Okay, stop, now you go. And essentially it's playing traffic cop with all, hundreds of different devices trying to access the web, like whether to and from, all this information. A lot of stuff is coming through the network. So to bypass that, generally you want to work with the IT team to set up what they call what do you call it? A sub-network, not a VLAN, not a virtual, maybe it is a virtual network, a VLAN, or like a separate network that's not on the same network as your participants. You want to separate this traffic, because if you have your stream, you want your stream uninterrupted. You don't want other people kind of cutting off your signal. Basically, think of it as cars, and they're cutting off each packet you're trying to send packets. Packets are like train cars or like cars, and they're going through the stop sign in order, right? And it's being received on the other end, being kind of compiled together into one continuous stream, right? Your streams that are 30 frames per second. Your network switch is going way faster than 30 frames per second. It's a gigabit per second, which is a lot faster. But still, you're going to have network buffering latency issues unless you have a single line from you to the network. And even from you to the network, then it's like your ISP. So in order to reduce any kind of latency buffering issues, you just want to have the cleanest line from you to your internet service provider as possible. Beyond that, it's out of your control. It's up to the internet service provider to make sure that your data gets to YouTube or Facebook or whichever. Yeah, so the buffering issues are going to happen from the network side. The latency issues could potentially be from your encoder, whether it be from your laptop or the encoder device. If you're getting some hardcore latency and you have time, just reboot and reset. Double check your settings, making sure that everything is kind of at normal settings, and try again. Audio sync problems. Why do audio sync problems happen? Audio sync problems used to be a bigger deal. Back before this is gonna be like, it could be a setting, but most likely, as long as your video and your audio are coming in at the same time, or in sync to your encoder, you should be good. It's going to compile, it's going to combine, the H.264 codec is combining MP4 video with WAV or MP3 file audio, right? So it's combining that at the encoder. So if you're having any sync issues, it's going to be before it hits the encoder generally. And ways to combat that, let's say, it's generally what's happening is it's your camera is being processed and hitting your encoder with a kind of buffer. So if I'm just speaking directly into this mic and my camera is laggy, right? You're gonna have that the camera kind of hitting the screen after the audio is hitting the screen, if that makes sense. So one way to combat that is in these certain instances, and it's going to be done at front of house from your audio console, where they delay the audio signal to match the video signal. Or you could even do it, like if you're doing it from OBS, I think there's a tool here. Maybe I don't have it. But essentially you're going to want to add a delay as an effect on your audio chain to compensate for the amount of delay that your camera is delayed from the audio signal. So if you do like a clap and you see, if you hear the clap before you see the clap, you're going to have to do your best to kind of calculate in your mind at first, or just kind of figure out how much difference the clap sound from the clap video you see, and kind of adjust your delay to that time. I mean, that's probably not a very good explanation, but that's all I got to fix the audio delay issues. I meant to hit this button. Okay, moving on to recording. The fundamental principles of recording is to get the best possible quality at the lowest amount of space. If you're recording audio, MP3 is usually the way to go. It's going to be a small file. If you're recording video, MP4 is generally the way to go. We're in 2024. Hard drive space is not that expensive, but video files are huge. So MailChimp, okay. Lol. Yeah, it's 2024, right? This is the current protocol, and then here's the new protocol. It smashes MP4 files, H.264's MP4 file with MP3 audio encoding. Jesus. Yeah, H.264 at 1080, let's say 1 hour. Generally, you're going to do 30 frames per second. Is 46 gigabytes. Consider this. Fuck off. H.264 at 720 is going to reduce your file size in half. Okay? If you want a higher frame rate, consider. So there's essentially two different. All right, so this is like ProRes. This is what you want. This is like full res, 1080 at 60 frames per second. If your cameras are shooting at 60 frames per second, you want to record at 60 frames per second. If your cameras are recording at 1080p, you want to record at 1080p. You don't want to lose your data, and you don't want weird things to happen to your data. So you want to kind of record at the same input bit rate and resolution as you're taking in. The problem with that is your file size. 100 gigabytes is a big file, and if you're doing meetings, galas generally are like only usually like 1 or 2 hours, but if you're doing meetings, 8-hour meetings, you cannot record at this high of a data rate. So honestly, unless you have, if you have the space, go for it. I don't know who has the space though, but this is what you're going to want to do. 720 at 30, and good luck. And you get yourself a nice video, here's a, where are we at? Blackmagic Video Assist. Takes an SD card. You put like 128 gigabyte card in here, and then how long? Let's say 128, right? So that gives me 4.5 hours of recording time. A 128 gigabyte drive. It's $21 on Amazon. Obviously, you want to record. What the heck? Dude, that's hilarious. I guess. Sorry, I didn't. It was definitely not intentional. I don't know why that is hilarious. Apparently, this is like a big. This is how they. This is how they're selling it, huh? It was only in the Google search. Very good marketing. That's hilarious. 2 terabytes. So, how about. Excuse me. That's so funny. Alright, so yeah, as you can see, these are pretty expensive. 2 terabyte SD cards. Worth it though, because you're going to need it if you're going to do full day events or something like this. So yeah, right now, I mean, I've probably burned up 23 gigabytes of YouTube studio space. So thank you, YouTube, for hosting this video. My poor computer is dying right now. Okay, so there's your recording formats. Recording devices such as cameras and audio recorders. I mean, those are generally self-explanatory. You're going to want to make sure that you're selecting the proper inputs on your audio recorders. You want to make sure that your gain is at a proper place to where, you know, your audio level is at a good spot. And yeah, for your camera, you're going to want to make sure that your format is at an appropriate format so that you don't burn out your memory too fast. Managing recorded files, obviously, like you don't want to move it too many times. If you have a Dropbox with terabytes of volume on it, maybe use that to hand off data to your client. Shipping data is not great. You don't want to like mail a flash drive or something that's, at least make a copy first, before you're mailing out stuff. The best way to do it, in my opinion, or my experience, is always using cloud-based services such as Box or Google Drive or something like that, or even YouTube, just hosting it on YouTube and sharing it with somebody, allowing them to download it, Vimeo, etc. And yeah, that's all I got. So 1 hour and 15 minutes about of your time was spent listening to me going over audio, microphones, gain, phantom power, compression, EQ, busing, speakers, streaming, going over the different streaming platforms, whether it's YouTube, CVent, Facebook Live, etc. Integrating audio, video, and graphic sources via video switcher, troubleshooting latency, buffering, and audio sync problems, and the fundamentals of recording, both audio and video, setting levels and selecting proper formats, and managing recorded files. So good luck, be safe, and let me know if you have any questions in the comments. We're going now. Bye.